models in future. Now this would be 14th and 15th. Let's continue today. So the first thing, let's introductions to deep learning. So here, so what do you think? What is deep learning? Deep learning is a machine learning technique that learns features and tasks directly from the data, where the data may be images, text, or sound, isn't it? In machine learning, okay, is a data which is numeric, which is labeled data. But deep learning, it's completely unlabeled data, which is unstructured data, isn't it? So this is the technique and features task from the data, and data may be images, text, or sound, isn't it? And deep learning, so is collections of deep learning is collections of neural networks, guys. So how many neural networks we have? We have three. The first one is artificial neural network. And then the second one is CNN. We can say convolutions neural network. And then we have the third one is RNN. So in RNN, we see recurrent neural network. Are you guys understand or not? So deep learning is collections of neural network, which is, deep learning frameworks are DL frameworks are deep learning frameworks are like, what are the things, guys? Like TensorFlow, Keras, and all those things. Okay, TensorFlow and Keras, and that's it. OpenCV, many more things we have. All those things we're going to understand one by one. So the first thing, so this is, now let's go ahead to the, before I talk about neural network. So before I come back to the artificial neural network, we discuss the human neural network, isn't it? So what is meant by human neural network, guys? So I'll give you some examples. Please try to understand. So 1 second. Okay. So here, if you see, the brain is made up of neurons or not, isn't it? And definitely one neurons are connected to multiple neurons. Agree or not agree, guys? So this is neurons. Who created the neurons? This neurons created by God, isn't it? And the next one, every neurons are, there is a some of things called dendrites, axon. Using help of these branches, it connected one neurons to other neurons. Are you guys understand? That's all about. We have a senses. Senses means five senses, five organs we have. So based on the senses, we can understand what is good, what is bad, when to cry, when to laugh, all those things. So this is called human neural network. So what is meant by artificial neural network? I'll come back to that, but before that, I'll give you a small examples, and then we discuss on this part, guys. So the first thing, let's say, assume you stand somewhere, okay, or maybe shopping mall, or maybe you book the tickets. A mosquito is bite on your left hand. A mosquito is bite on your left hand. So I mean to say, let's say when the mosquito bites, you see from eyes or not, guys, isn't it? So when you take an input layer, and then, so in the left hand, many neurons we have in our body, isn't it? The moment the mosquito when bite, the specific neurons are activated, isn't it? And then immediately pass the signal to the brain. Are you guys understand or not? Immediately pass the signal to the brain. So brain, this is called input layer. What we call, guys? Input layer. So what are the activations? The moment when mosquito bites, what happened? The signal pass from hand to brain. So brain is hidden layer or not? So input layer, we see the performance through eye, and process through hidden layer. Hidden layer, it pass the signal to the right hand and saying, please do something, it's get hurt, isn't it? Do you understand? So what is the connections? The connections is very simple. We have some input layers, we have some hidden layers, and we have some output layers. Do you understand what I'm saying? So definitely in this, so this is input layer, this would be hidden layer, this would be output layer. The reason why I'm giving example, same things we plant in the TensorFlow architect as well, architectures of neural network. I mean to say, as I told you, when the mosquito bites on a specific place, the neuron is activated from entire left-hand neurons, and then it passes the signal to the brain. In the brain, neurons are activated, and then it passes the signal to right hand, and it's saying please kill the mosquito, so that, are you guys understand, this is called architectures, and this is what we have human neural network. Are you guys understand or not? This we have like human neural network. Now, what is artificial neural network, guys? So today we discuss, before I talk about, before introductions of ANN, let's start with architecture of ANN, neural network. Are you guys understand or not? Architecture of neural network, we understand. Now the next step. Okay. So as I said, look at this. This we have input layer, hidden layer, and output layer. Are you guys understand or not? This, see, one neuron is connected to multiple neurons or not? Then only the signal pass, or else it don't pass, isn't it? So here I'll give you a small data sets to you. So this would be input first. We create input layers. This would be input layer. This would be hidden layer, and this would be output layer. This is architecture. So I already gave you the example of human neural network. What is architectures? We see the data through eyes and signal process from input to hidden and hidden to output. Are you guys understand or not? In this architecture, in this architectures, how many hidden layers we have, guys? Only one layer, only one hidden layer. So this concept is called as single layer neural network. This concept is called single layer neural network. Are you guys understand or not? This concept. What is meant by multi-neural network? Assume if I add another, so for example, I'll create, now just one moment. This would be input layer. This would be input layer, hidden layer 1, hidden layer 2, and output layer. Are you guys understand or not? So when you pass the signal, this is called single neural layer or multi-neural network, guys. More than one hidden layer is called multi-neural network. Are you understand? So where we have only one hidden layer, guys, are you understand or not? What is multi-layer neural network? So this is called where we have more than one hidden layer. Guys, are you understand or not understand? Up to this, everybody's clear. So what is the thing? Today we understand architecture. In architectures, we have one input layer, and then one hidden layer, and then one output layer, right? So see, in the mosquito example, we have input layer, means when the mosquito bites, we see from the eyes, means we take the data through eyes, and it passed to the brain, hidden, and hidden brain passed to the right hand. But here, one thing we miss, the mosquito bites means activations or not. I will talk about activation functions. What are the activation functions we have? We will discuss everything. But before that, I'll give you one example once again. Listen to me very carefully. I'm going to plot a little bit diagrams on it. So for example, if a student study for 4 hours, are you guys understand or not? And if the student sleep for 8 hours, if the student play for 2 hours, and his result is he passed the exam. Are you guys understand? Assume I have some of the records we have, isn't it? How many records, guys? Assume some of the records we have. one of the students information. So how to create a neural network for this data we will discuss. Understand, guys? So the first thing, we create a, so this is called sleeping or studying, and this is called sleeping, and this is playing. Are you guys understand or not? And input layer, this should be the hidden layer, this should be the output layer. Understand or not? Now let me name it. So I'll name it as x1, I'll name it as x2, I'll name it as x3, I'll name it as x4, and this would be output. Output means what? Y hat, isn't it? What is, guys? Y hat or not? Isn't it? Model predicted is called output. I can mention this would be input layer, this would be hidden layer, and this would be output layer. Now let's pass the signal x1. So do you remember, if I pass the signal from x1 to x4, we pass like this or not? The arrow mark. So do you remember, in the world, everything's the weights are associated with it. So can we say W1? Isn't it? What are the weights? Each and everything's weights are associated with it, guys, isn't it? So this would be the W1, means X1 to input layer to hidden layer. What are the W1? I mean, weight is W1. This would be W2, isn't it? This would be W3. Understand or not? And let's see this, guys. We have neurons, entire body filled with neurons, isn't it? If something happened, then only it activated. Are you guys understand? Then only the signal pass, means we need to apply activation functions to here, this neuron, activation function to this neuron, activation function to this neuron. Then only the signal pass to hidden layer. Then only the signal pass to hidden layer. Once the signal pass to hidden layer, can I say the equation is x1 w1 plus x2 w2 plus x3 w3, or summation of I n equal to 1 xi wi. Can I write these equations over here or not? Are you guys understand? Can I write these equations over here? When I write these equations over here, now how I pass signal from hidden layer to output layer? Again, we need to activate it. Again, we need to activate it or not, guys? I mean, when you, from the mosquito bites, the signal pass to hidden brain, and brain also activation is going on, then only it pass the signal to right hand, guys, isn't it? So then we need to activate this. Once we activate, what happen? It will pass to output layer. It will pass to output layer. So output layer, what exactly happened? The student pass or fail, guys? The student pass or fail? Let's assume the model is predicted fail. Let's assume the model is predicted fail. Are you guys understand or not? Is it accurate prediction? No, this is not a accurate predictions. Now, so here y hat equal to 0 and y is 1. Agree or not agree? Y equal to 0, y equal to 1 and y hat equal to, this concept is called forward propagation. What we call, guys? Forward propagations. What is forward propagations? In music, are you play forward button or not? What's meant by that? A little bit fast on whatever you watch in it. I guys understand? In forward propagations, what we say, we have only, so this is wrong prediction. So what you do, what is loss functions, guys? What is loss function? What is loss functions? Actual minus predicted or not? So y minus y hat, isn't it? Y minus y hat. And what is gradient descent? In gradient descent is an optimization algorithm to reduce the loss function and increase the accuracy, isn't it? When we reduce the loss, actual minus predicted, the accuracy will increase or not, team? So this is called optimization. So how to reduce the loss? Let's go ahead. What I'm going to do, y minus y hat. What exactly I'll do, guys? Y minus y hat means I need to reduce the loss, then my accuracy will increase. So when I reduce the loss, what happened? 1 minus 0, and also to change this one here, W4. Are you guys understand or not? I'll do a back propagations. I will do a back propagation. So my question is from output layer to hidden layer. See guys, architecture is same on every neural network. Same architecture you will implement in ANN, CNN, and RNN. So architecture is always be constant. It won't be change, isn't it? Now my question is, when we do a back propagations, when you do a back propagations from y minus y hat, which is loss functions, guys, in the loss functions, can you please respond me? What was original weight, guys? In forward propagations, what was the weight of it? W4. So in back propagations, can I assign same weight or weight will change? Same weight or weight will change? Weight, online team. Same weight or weight will change, guys? The weight will change. How the weight will change? Can you say it will update to W4 new? W4 new. So here the equation of W4 new equal to W4 old minus learning rate derivative of loss function divided by derivative of old weight. And this is what formula implement in the background, and W4 will change to W4 new. Did you understand, guys, what I'm saying? What is the formula? W4 new weight equals to old weight minus learning rate. Learning rate is always minimum or maximum? Learning rate always minimum, guys. So when we minimum, so when we derivative of loss, I hope in +2 you guys work about derivative and integrations or not. Yeah, so when we have derivative of loss functions divided by derivative of old, I mean weight, what happened? The weight will be difference. And now next step, are you guys understand or not? From hidden layer to input layer, what would be the new weights I will assign? W3 new, and same goes to W2 new, and this one also W1 new. Are you guys understand? So I can write here one forward propagation plus one backward propagation is one epoch, one iteration. Are you guys understand? And this is what interview questions. What's meant by epoch? What's meant by epoch? Epoch is one iterations. That means one forward propagations and one back propagation is called one epoch. Are you understand? Next questions. What are the fine tune of weights? When the weights will adjust, guys? Forward or backward? Forward or backward? Backward. So at backward propagations, the weights will adjust. It forward propagations is not gonna adjust, guys. Did you understand him what I'm saying? So how exactly happened? My question actually still what happened, guys? Actually, this is 1, but model predicted is 0. Now, what is the next step? The next step, can we do a second epoch? What is second epoch? I mean to say, what was the weight? W1 or W1 new, guys? W1 new. Now, when I do the next time, when I do a forward propagation, this W1 become W1 new. Agree or not agree? W1 become W1 new. Once the W1 become W1 new, and then W2 new, and W3 new, and then goes on, and then W4, it's activated, apply here, and then W4 new. And this accuracy 0 become 0.4. 0 become 0.4. In first epoch, what happened? The accuracy increase 0 to 0.4. What is the next step? Can we do a second epoch or not? Can we apply again loss functions? What is loss functions? Y minus y hat. So 1 minus 0, and then again do W4 new becomes W4 N1, isn't it? And then W3 N1. W2 N1, W1 N1. At second epoch, the accuracy we got 0.4. And third epoch, what happened, guys? W1 N become W1 N1. And then what exactly happened? W2N1, W3N1, W4N1, 0.4 become 0.8. Team, can we continue this? So what do you understand? If you do multiple epoch, the accuracies are increasing or not, guys? Online team, are you guys understand or not? Online team, are you guys understand? So when you do multiple run, what happened, guys? What happened? The accuracy will increase. The accuracy will increase. So I'll talk about this one now. So here, if you see this, see x1, x2, xm. Is this forward propagations or not? These are the forward propagations. In forward propagations, we use summation m wixi. So look at the formula. The equation would be w1, w2, w3, w1 x1, w2 x2. Definitely, it has to be activated. It has to be activated. It has to be activated. Then only I told you the mosquito example, guys. Okay, and then x1 w1, so w, and then again it will apply the activation functions. We pass the signal to it, guys. Are you understand or not? Everybody clear, guys? What is the back propagations from the forward propagations? This also called feed forward cycle. What we call, guys? Feed forward cycle and back propagations. I'll go ahead and let's forward propagations, also call feed forward cycle, and back propagations, what we called as back propagations, what we call, guys? I think, okay. Or you can also backward here, backward propagations. Okay, team. And 1 FP, 1 BP equals to 1 epoch. Agree or not? So using multiple epoch, the loss functions will reduce and accuracy will increase. Team, are you understand or not? Using multiple epoch, loss functions will reduce and loss functions will reduce. So here in this example, let's close this and I'm going to show some of them. Neural network back propagations. Okay, let me open this. I'll give you in detail. Back propagations in deep learning. Back propagation is the essence of neural net training. It is the method of fine-tuning the weights of neural net based on the error rate. Back propagation is short form of backward propagations of error, isn't it? It is a standard method of training artificial neural networks. Go to the next one. Okay. So listen to me. So we have x1, x2, xm, w1, and we apply the formula at a hidden layer and then activate it with this one. Just now I said this is y hat and this is y. And let's assume if actual is 1, the model predicted 0. There is a cost is there or not? What is the cost functions? Y minus y hat. Did you see some errors are there? So what we do, the next step, we do a back propagations or not? The moment when you do back propagations, what happened? Did you see? We mark here. These weight will be changes. The weight will be adjust. You will get updated weight. You will get updated weight. Okay, so that's called weight updations. In artificial neural network, weights will update. In convolutions neural network, filter values are update. What are the filter values? I'll get back to that. No need to worry. Okay. Next one. So listen to this. If in the first epoch, what exactly happened? The exam score, we got 93 percentages. What we got, guys? 93 percentages. This is the first epoch. We got 93. Now let's go to the second. So how many epoch we done on this graph, guys? How many epoch we done? 8 epoch. 8 epoch. In the first epoch, look at this. 8 epoch means 1, 2, 3, 4, 5, 6, 7, 8. Isn't it? 8 epoch. Epoch means what? One forward propagations and one back propagations. In the first epoch, do you think y and y hat are equal? No. Little bit cost functions are there or not? And second epoch, what happened? Both will reduce, guys. In third epoch, why? I mean, did you see in backward we adjust the weight? In backward, see, everything is you can't see how the system runs, the TensorFlow runs about this, guys. So I just give you example to make you understand. In this one, both are a little bit same, and finally in this one we get 93 accuracy, 68, 95, 75, and finally we build the model with 97% accuracy. Are you guys understand or not? Are you guys understand? So online team, I hope everybody's clear. So this one, and finally this cost function is, I mean, the optimizer. What are the optimizer, guys? Gradient descent is an optimizer or not? What is other optimizer? Stochastic gradient descent. What are the other optimizers, guys? Stochastic gradient descent. What are the optimizers, other optimizers? Batch gradient descent. What are the other optimizers? Adam, add a grade, add a delta. Okay, RMS prop. All these optimizers we have. So mostly you can use GD, or Adam is the common one. And because, yeah, Adam, lazy Adam, all those things we have. Lazy Adam also we have, guys. No, is it? I need to check. But add a delta, add a max also we have, add a max. And these optimizers we have. And by default we use as one epoch will 7 input will feed, or each we will have one forward row by row. Yes. So in one epoch, all 7 input will feed, or each input will have one. No, every input will have one for. So I'll give you one example, guys, again. Okay. So very simple. We can have 3 neuron, like you can create a 7 neurons as well. First, I will explain theory. Tomorrow I go back to the practical. The theoretical part will take around 1.5 hours. So today we'll take some time, and tomorrow also we can use some time, guys. Okay. And then this is called one hidden layer. Means it will connect to everywhere. Are you guys understand or not? Even though if you have another hidden layer, it will connect to all those things. Understand, Sashri? And then here, so it doesn't matter how many neurons we have, but it must be this neuron. We need to connect the layers, right? Signal we pass. What exactly we passing, guys? We passing signal. In code, I will tell you, we have some libraries to take care of these things, guys. In code, some libraries that take care of it, isn't it? So here, everywhere these neurons are connected to neuron, means the forward propagation should happen. Forward propagation should happen. Forward propagations. Now this one, again, forward propagations. Can you know how many hidden layers are there? You can build plenty as you want. So it's not limitations like that. How many hidden layers? Okay. Yeah. So all these things system automatic choose, but we can assign. I will show you practical, then only we can understand. Sashi, I hope, are you clear? I mean, row by row. Yes, row means in that side having 8 rows. Just want to wonder whether each row slide. Okay, which slide? One moment. I'll open the slides here. This one. Yeah, row ID means it is one epoch. Row ID means one epoch. Understand? So remove this. Okay, so this is epoch. Okay, yeah. So guys, one epoch means first epoch we got 93, second epoch we got 60, 95. Sometimes it increase, sometimes it is decrease. I hope understand, guys. But remember, we need to reduce the cost. 8 epoch here, that's right, 8 epoch here. Now, can we increase the epoch? Yes, we can. But when you have actual equal to predicted, what else? There is not required of do these things. But there are few problems you'll occur in upcoming days. I'll tell you what are the vanishing gradient descent when we do the forward. But here I wanted to highlight in one thing, that the new weight formula is equals to old weight minus into learning rate into derivative of old weight and derivative of loss functions divided by derivative of old weight. You understand, guys? These are the weight upgradations formula. I mean to say, let's say I have two neurons, one hidden, one output layers. I pass the signal. This would be the forward propagations, and x1, x2, and x3, and y hat. This would be w1. This would be w2, w3. If the y is, this is y, then we do a back propagation. So here we get w3 new equal to, this is old w or not, minus learning rate derivative of loss divided by derivative of w3 old, right? This would be the formula. Same formula applicable here. So I mean to say, in the real-time data, if you have like what we said, these things you cannot do manually. At the third epoch, we have same y, and we are going to again epoch. No, I didn't say that. Are you guys getting my point? At the third epoch, we have same. It may be same, it may not be same. You can't decide that, isn't it? It may be same or may not be same, guys. I'm giving you some examples, right? So here in this graph, the epoch is on 8. It stops because you mentioned in random forest algorithm, do you remember an estimator? What are the maximum n estimator, guys? What is the n estimator? 100 or not? Means you build the take decisions from 100 tree, isn't it? Can't you assign 1000? Can't you assign 500? It is a user defined. The epoch, if you mention 3 times epoch will done. If you mention 300, 300 epoch will done. Ranjit, I hope clear. Now here the same things. In here it is 200, then 200 epoch, 200 trees. And 300, 300 trees will be getting. You guys understand? Everything has to be user assigned at the time of code. User assigned. You can't fix it. This is not by default tuning. Are you guys getting me? Okay. Now, next, minimize. Okay, so adjust part. So guys, are you clear? So today, what we discuss? So today we discuss a few things before I go ahead to another topic. We covered up like intro, what is a human neural network versus, and I can say in an artificial neural network, isn't it? We discuss what is forward propagations. We discuss what is back propagations, what is epoch, and what are the weights, and what are the weights formula. Okay, what are the weights formula, and how to adjust the weight, and how to adjust the weight, and how many optimizers we have here, optimizers we have to reduce the loss function. Whatever explains, same things are explained in the practical. Okay, then things would be very clear. How many optimize we have to reduce the loss functions, all those things we done today. So these topics are important in interview if anybody asks. And we also covered architecture of neural network. You guys understand? We covered architecture of neural network, and then we have human neural, we have forward propagations, back propagations, epoch, and weight, and this one. So, clear or not clear? Perfect. Now the next step, activation function. I told you, right, when a mosquito bites on left hand, we see the of operations through eyes. We take data using input layer and we feed to the brain, which is hidden layer. When the mosquito bite on left end, in the left end, many neurons are there, but one neuron is activated. All right, guys, but one neuron is activated. I mean, I have X1 input, we have X2 input, we have a hidden layer output. Now, definitely this neuron has to activate to pass the signal, isn't it? If the neuron is not active, it never pass the signal. So in deep learning, we have few activation functions, and those are okay. But before I go back to this one, multi-neural network, I hope we discuss, guys, what is multi-neural network, isn't it? And then architectures also we covered this one. Back propagations also we covered, right? Now the next one is how neural network works. Already I told you, but be better. I will explain this one. More epoch means more will be learning from existing data. Think this will be also elbow curve like K means we did. No. Elbow is different, but yeah. So you know it to be that is different. This is different, Sashi. I mean, I will you can understand. You can understand when things goes up. All right. Yeah. Activation functions. Activation functions is very important. Activation function will be very important. Now I will mention some of the activation functions here and listen to me very carefully. And we have 6 activation functions. The first one is threshold. The second one is sigmoid. The third one is tanh. The fourth one is relu. The fifth one is leaky relu. And the sixth one is softmax. How many activation functions we have? We have 6 activation functions. So the first one is threshold. See, all those things you will implement in practical. So see, deep learning, I can speak the theory more than 1 week, but not required. I will tell you the summary, that's good enough. Are you guys understand or not? And now threshold, and then sigmoid, and then we have tanh, and then we have relu and leaky relu, and then we have like softmax. Understand or not? Threshold, we can implement. Threshold is a function. So yeah, this also we can take as activation functions. And this is used for binary class classification. What is the binary class classifications? I hope you understand or not. Copy and this one also, and also this is multi-class classification. Understand? Exclude softmax. We have, yes, binary means 0 and 1, isn't it? Exclude softmax. Rest of them are binary activations, guys. Binary class classifications means cat or dog, right? Smile or not smile, happy, sad. Okay, so this is this kind of things, guys. Now, do you remember in threshold where exactly I taught you guys? In logistic regressions, I gave you one example as if the patient's 2 conditions I assigned, I gave you, might be you forgot. If the customer's weight is greater than equal to 50, predict, or maybe 60, predict he's a diabetic. So less than 50 is a non-diabetic, so 0. So we required some of the threshold functions or not? So 0 plus 1 by 2, the threshold is 0.5, and based on that we can say 0.5 to 1 it is 1, 0 to 0.5 it is 0. Did you understand or not? Actually you can skip this point. Actually you can skip the first point, threshold. In practically we not use, but rest of things we can use. So in the one, what happened? If we plot the best fit line, if the patient's weight is 70, it will predict 0 or 1, guys. 1 or not. So we already covered that in logistic regressions. So that's what I'm saying. If you do not understand machine learning, then you never understand the concepts of this one. So let's go back and we threshold functions. Do you see threshold functions always give you output is 0 to 1? Agree or not agree? Isn't it? Always it will get implemented as 0 to 1. So that's why threshold activation functions we can update as in the activation functions in it. Okay. Next step. This is very important. Sigmoid. What is sigmoid curve, guys? Where do we discuss this one? Logistic regressions. We get sigmoid. Why we get sigmoid graph or why we get sigmoid curve? Because because no, because if the data has outlier, non-linear, okay, that is non-linear, that's fine. But why we get sigmoid? See, this is if you answer non-linear, you're never gonna crack the interview, guys. Misclassifications happen because if the outlier is added, the shape of the output will be changed or not. Exactly, for outliers. So outlier means what? Even though the outlier we feed, the outlier can skew the data between 0 to 1 or not, using help of sigmoid function, sigmoid curve, probability functions. I already told you. If not, I want you to go back and understand those things, guys. So my question to you, the sigmoid curve looks like a shape. And do you remember we get this curve or not? What is a sigmoid curve range, guys? 0 to 1 or minus 1 to 1? 0 to 1. Sigmoid curve range is between 0 to 1. So that means even though outliers we have in the data, it's skew between 0 to 1 or not. It never cross, it's never go beyond 0, it's never go beyond 1, isn't it? The data will always between 0 to 1. Then my question in, listen, think and answer me, guys. We have sigmoid curve or sigmoid activation function. How many layers we have? Input, hidden, output. So this is input, this would be hidden layer, this would be out. My question, where do you think the sigmoid activation functions will implement? Input layer, hidden layer, or output layer? Think and answers. See, yeah, when he said hidden layer. What about others, guys? Where do you think it will be implemented? Very good. The answer is output layer, because no matter what the outliers is there, the data will stay at output layer, whether you get 0 or you get 1. That's it. So always, so let me write down, guys. Remember this one. The sigmoid activation function, sigmoid activation, sigmoid activation function always implement in which way, guys? Which layer? Output layer. Remember this one. Never ever implement in input layer and hidden layer. Why, guys? The reason being, let's say we have two input layer, one hidden layer, one output layer. If you apply the sigmoid here, the data will stop here. Who will pass the forward next step? Did you understand? If you apply here, what exactly? It will give you output 0 or 1. So it won't pass to the next layer. Online team, are you getting me what I'm saying? Even though if you apply hidden layer, it stop here. But we don't want to stop here things, right? We wanna just run another epoch and then we get output here 0 or 1. This would be the perfect for this. Am I clear? So sigmoid activation functions you never ever implement in input layer and hidden layer. And what is the range of this activation functions, guys? 0 to 1. So what is the range of these activation functions? Sigmoid function, a activation function will range between 0 to 1. Agree or not? And what about this binary activation function range is also 0 to, are you guys understand or not? Okay. No, see, don't think too much. Okay. It should activate input neurons. So input, I'll come back. Let's complete and one will get back to this. Sigmoid, have we completed? What is the tan H? So what is the tan H, guys? Okay. The tan H means, let's talk about that. Do you remember sine theta by cos theta? When you do the formula, what is the ranges you get between -1 to 1 or not? So here, the tan H also activation function, it ranging, it also implement at output layer only if the data has negative values. You guys understand? And then the range of the tan H function is -1 to 1. So interview question, what is the difference between sigmoid versus tan H? Are you guys understand? What is the difference between sigmoid functions versus tan H? Would you explain them or not? Would you explain them or not, guys? So right now, the next question is, sir, if we activate the neurons at output layers, then who will activate the input layer, hidden layer? Let's coming to the next step. So one we done, second is done. Let's go to third also done. ReLU. What is mean by ReLU? So the ReLU, look at this, guys. The tangent represents a ratio between opposite and adjacent side of a right triangle. So tan theta equals to sine theta by cos. Unlike sigmoid functions, the normalized range of tan h is -1 to 1. The advantage of tan h is that it can deal more easily with negative numbers. See, in the code, we write as a parameter as a activation equal to sigmoid, activation equal to tan h. Then only the neurons pick the user's query and then process based on the input, user's input. Did you understand? And the next one, ReLU. ReLU full form is rectifier functions. What is the ReLU full form, guys? Rectifier functions. Okay, what is meant by ReLU functions does? So I'll mention ReLU means we can have here rectifier functions. So what exactly mean by ReLU, guys? Listen to this. ReLU, if you see the formula of the ReLU is max of x comma 0. What is the formula? Max of x comma 0. When we apply a max, can you tell me max of -1 comma 0? So what is output, guys? Max of -1 comma 0. What is maximum value? -1 or 0? 0 or not? I mean to say it never be get based on this equation. Will we get negative, guys? Based on these equations, will we get negative or not? Now, when we don't have negative, so what exactly happen? Max of x comma 0, then I can say, can we say max of 10 comma 10 cr? We get 10 cr or not? Means there is a no limitation. So that's why the range of ReLU activation function is, just one moment. Anybody, guys? Any guesses? Why you said -1? The range of ReLU activation function is 0 to infinity. 0 to infinity. And do we have negative values, guys, over here? We don't get negative. And this ReLU we will implement in regression. ReLU we implement in regression. Now my question, regressions means we should pass the maximum values or not? We should pass maximum values. Now my questions, I have input neurons, I have hidden neurons, now I have input. Anybody tell me where I'll implement ReLU now? I hope you got the answer. Where you, input. Excellent. Input, because this is input layer. So we'll feed maximum value to hidden layer or not? Online team understand now? And what exactly this? Can we apply ReLU or not here as well? This is regressions because the data is continuous. We not classify here. The classifications done it here 0 and 1. But in this case, we have to pass the maximum data from input to hidden layer and hidden to output layer. I mean to say, let's say this here I will implement ReLU activation function. Here I'll implement ReLU activation function. Here also, what is the formula? X1 W1. So the formula is equal to X1 W1 plus X2 W2, and then ReLU activation functions. Then only the signal pass to hidden layer. Then only the signal pass to hidden layer. Online team, I hope it's very clear. So next one, so can we implement the sigmoid at output layer or not, guys? Sigmoid at output layer. Now let's continue this, guys. So remember, ReLU activation functions we always implement in where team? Input layer and hidden layer, not output layer. Okay, tan edge we understood. So range between this one and let me implement in regressions. ReLU activation function we implement in where, guys? Input layer. See, look at this, because when we have max part, so definitely we have to pass it or not. And then we need to do this next one. Leaky ReLU. ReLU is done. What would be the leaky ReLU, guys? Let's go ahead to the next step. The leaky ReLU means if leaky ReLU function is an improved version of ReLU, as we saw that for the ReLU functions, the gradient is 0 for x less than 0, which made the neurons die for activations in that reason. So leaky ReLU is defined to address problem. Instead of defining the ReLU function as 0 or x less than 0, we define it as a smaller component. Means in ReLU, do we have negative values, guys? No. In ReLU, we don't have negative because the formula is max of x comma 0. When the formula is max of x comma 0, so we always considered max is the value, right? And then here, leaky ReLU, it will considered when the data is negative. So the range of leaky ReLU, anybody answer, guys? -1 to infinity. -1 to infinity. Team, did you understand? So here, ReLU and leaky ReLU, it's working type of regressions. Sigmoid, tanh, and threshold, it work like a classifications. And all these things we implement at output layers. Online team, are you guys understand or not? Online team, I hope you guys are clear. Now the next one is called softmax. Softmax. See, look at this softmax for multi-classification. So we have binary class classifications. If we have dog, for example, I'll give you an example. Did you see there's a dog breeds are different or not, guys? So when you say you wanted to predict the dog, and if I say the world dogs, so you can have multi-class or not, guys? Multi-class. So to multi-class classifications, we need to implement softmax. What we, guys? Softmax. All those things for multiple classifications also, I will show the practical and we understand one by one. Okay, guys. Now the next one, softmax functions calculates the probability distributions. So how many distributions we have? How many distributions we have, guys? Normal distributions and Gaussian distributions, uniform distributions. Also, we have probability distributions. What we have, guys? Probability distributions. What is the probability? And remember, if I say, when you type in Gmail, hi, How would you automatic come up or not? There is a probability. It could be how, it could be any other words as well. So in text and in image, always implement in what we guys softmax activation function. So probability distributions. So remember, you can also ask to anyone, the one who learning data science in the world, you can go and ask, where did you implement probability distributions? Okay, I don't think so they will answer, guys. All right, and do you remember in clusters there are few new algorithms I told you, like UPGMC, all those things, and also maybe you forgot. Okay, so I want you to see, I told you a lot of things, guys. Right now, if I sum up all those things, have you mentioned all those things in resume? If not, please do that. I'll tell you summarizations, what we done. There's a many things we covered: cross validations, feature scaling, feature engineering, and then activation functions, what we guys, maximum hyperplane, Gini, entropy, all right, regularizations, and GD, SGD, and tuning, how to update kernel functions, okay, PCA, practicals, many things we done within the short span of time. Do you understand, guys? Now, after complete the algorithms, if you turn up any book, books will be easy. Prior to that, books are tough. Now you open, everything would be easy. But one condition is, if you listen well, things would clear. Anyway, let's go ahead to the. So this is the softmax. So look at this. The calculate probability of each target class and over possible target class. The main advantage of using softmax is output. No, these are the theories I have to explain, because I cannot directly open the practical and show to you. It's not going to work out. First understand theory, then practical, then you like it. And it will be print in your brain, isn't it? And then the main advantages of, yeah. So the main advantage of using softmax is the output probabilities range. The range will 0 to 1, and the sum of all the will equal to 1. In softmax multi-classifications model, it returns the probability of each class, and target class will have hype, and the equations are, this is one exponential summation j exponential of xj. Okay, so I can say here the softmax used for what, guys? The leaky relu, when the data is non-linear, and you can implement this, and the range of leaky relu is what, guys? -1 to 1, -1 to, sorry, infinity. Softmax used for what, guys? Multi-class classifications. Okay, you never implement when the data is binary. When the data is binary, isn't it? Softmax and the range of, mostly where do we use, guys? We use softmax at image class classifications or text class, multi-text class classifications. And the range of softmax is 0 to, agree or not agree? I hope all activation functions are we completed, isn't it? So how many activations we have? In interview, don't talk about threshold. That's okay. You can ignore, but you can say rest of them. Okay, you can say rest of them as sigmoid, tanh, relu, leaky relu, and softmax. In organizations, mostly we use sigmoid and relu, leaky relu, and optimizers. We have like, let me check, did I miss any optimizers? One moment, and I can ask here so that I can find out. Optimizers in ANN, and I think we have all these optimizers, list of optimizers, we will get it. One moment. Okay, so these are the things, guys. As I told you, gradient descent, stochastic gradient descent, mini batch, add a grader, RMS prop, add a delta, atom. That's it. Whatever I mentioned, you don't find more than that. Are you clear? Okay. And what are the loss functions we have? I will try to talk about that. What are the loss functions we have in ANN? So loss functions, we have regressions and we have classifications, isn't it or not? In regressions, we see MSC, MAE, mean squared error, mean absolute error, isn't it? In classifications, we have loss class like cross entropy, binary cross entropy, and then category cross entropy. Are you guys understand or not, guys? So these are the loss functions we will implement. Okay, and also I will check a little bit on this for loss functions and deep learning, and I can check this out. If log loss also there, I think. Okay, so go back. Okay, so loss functions cost. Okay, as I mentioned, did you see regressions, MSC, MAE, and Hubble loss? This is not required. Okay, whatever I mentioned, the same things. Classifications, binary, and category cross entropy, and autoencoder. We have KL divergence. I mean, all those things we have, guys. Okay, and mean focal loss, all those things we have. By better, I will share this link too for better understanding, guys. Are you clear or not? See, the topics which I covered, it's summarize of everything. You don't need to be worried. Are you guys understand or not? Even though if I share you this much of book, you not understand. I guys understand? So now whatever I'm saying, just refer to that, make a document, go and sit in front of interview. You speak well. That's why my students getting placed, just not like that, guys. The students complete many of the courses and they come back. And now the concepts are clear in my program. Let me tell you, MLOps is not a class. MLOps is a deployment phase. That's it. Do you understand? The one which you're learning is core part. Am I clear, guys, everybody? Okay. So there's no separate things called MLOps. MLOps, we can deploy the model in multiple way, like in Collab, in where I mean, even though we have Azure, we have AWS, we have GCP, we have Streamlight, we have Heroku, and we have database. Deploy the model. These are the tools based on the company to company they're using. That's it. For MLOps is not a separate course. Don't think too much. Some of people, they misunderstand. Are you guys understand or not? Okay. And when they say data science course with ChatGPT, oh, it's kind of money-making schemes, guys. They try to fool the people. Please don't trap on all the fools. Just follow me, learn and apply. Let's get into job. Am I clear or not? So let me close this. I hope I mentioned what are the loss we have, guys. I think two losses. Yeah, two. Close this. So guys, are we clear today? Now I think I'll stop here because it's too theoretical today. And I know it will take some time to digest all these things. And I will explain tomorrow few concepts like vanishing gradient descent, regularizations, drop out the neurons, and what is global, what is local, and all those things we discuss. All right, team, all the things we will discuss. And then we built one model in CPU, and then we build the model in GPU as well. So Google Colab, all these things you can work using Google Colab, but I'm not suggesting to Google Colab because you connect to the Gmail, isn't it? G Drive. In organizations, no G Drive is there. In organizations, Gmail you cannot open. That's a credential. It's because you shared the data through Gmail, it would be private confidential or not. So that's why Google Colab, a lot of trainers, they will suggest, but I never say to do to student because you need to learn how to install on your laptop, you must need to understand. And that's what you do yesterday. You're so much enjoying when you install, isn't it, guys? You will enjoy the classes in upcoming where we start rest of the sessions. Okay. And that's it. See, World Dog used for multi-class, or else your people misunderstand what is meant by World Dog, all those things. Okay. Thank you, guys. And we'll connect tomorrow, and we in neural network also do regression. No, in neural network also we do regressions. See that if you see this graph, the one which I showed, the score, the 8 epoch which you ask a question, that is a regressions only. Okay, one moment. Let me go back and back propagation. See, this is a look at the score. Regressions or not? Continuous 9368. Yeah, you can apply both regressions and classifications. No problem, guys. All right. And that's it for today. And I want you to, I will share all these documents tomorrow, and we'll continue the rest of things like that. All right, guys. Thank you. And you have a good day, guys. Bye.